Morning guys. Today we're going to take a look at page 16 of the Unit 4 Classwork packet. I think that the number may have gotten cut off on this one, so I apologize. You'll know it because it's the one that says parallel lines, perpendicular lines, coinciding lines, and negative reciprocals. Okay? Now, what we're going to talk about today is how to identify whether lines are parallel, perpendicular, coinciding, or, well, none of the above. Okay? Parallel lines have two characteristics that we need to know. They have the same slope. Let me say that again. They have the same slope, but different y-intercepts. Same slope, different y-intercepts. Write that down. Write it down. Perpendicular lines, by contrast, have opposite reciprocal slopes. Let me say that again. Perpendicular lines have opposite reciprocal slopes. That means flip it upside down and change the sign. Coinciding lines are similar to parallel lines in that they have the same slope, but they also have the same y-intercept. Let me say that again. Coinciding lines have the same slope, but also the same y-intercept. Okay? Now, in order to take a look at how this is going to work, let's take a look at example number 1. Okay? Example number 1. And before I even write down this problem, just a word of advice. You will need to remember the slope formula. Okay? y2 minus y1 over x2 minus x1. That will be used in order to calculate slope here. All right, so I got negative 2, 3, and what is that, 2, 6. And then for C and D, I've got negative 1, 0, and 3, 3. Got it. And I'm just gonna draw a little squiggle down here so I know that these are A and B, and these are C and D. Like these are the 2 points I'm using for the first slope calculation, and these are the ones I'm using for the second. Okay. First things first, before I can classify the lines, I got to know their slopes, right? So let us find the slopes. So y2 minus y1, so for the slope, 6 minus 3. And then over here, what's the slope over here? That would be 2 minus negative 2. When I say slope, I meant x2 minus x1, right? So that's going to give me 3 over 4. Okay, so that slope's 3 over 4. Let me just keep that in mind for a second, okay? Then I'm going to come over here and do the same thing. Let's find the slope of this one. So 3 minus 0 over 3 minus negative 1. Okay, so that slope's 3/4. Okay, so here's what I know now, right? I know that the two lines have the same slope, okay? That only tells me that it could be parallel or it could be coinciding. So what I'm going to have to do now is I'm going to have to find the y-intercept, okay? And I'm going to show you my preferred method. My preferred method is actually to use point-slope form from Algebra 1, but there's actually another way to do this by plugging into slope-intercept form. So, well, it's up to you. Okay, so here's my preferred way, okay? My preferred way is to use point-slope form. So y minus y1 equals m parentheses x minus x1. And then what I'm going to do is I'm actually going to plug in. So I'm going to use this 2, 6 here. So I'm going to say y minus 6 equals 3/4 times x minus 2. To convert this to slope-intercept form, I'm going to have y minus 6 equals 3/4 x minus, well, that's 6/4, right? And then I would add 6 to both sides. So y equals 3/4 x. You guys actually see what I'm doing? Let me kind of move that down for you. 3/4 x minus 6/4 plus 6 over 1. So if I were to convert that, right, to a fraction, multiply top, or equivalent fraction with the same denominator, multiply top and bottom by 4. So that's 24 over 4. And 24 minus 6 would be 18. So y equals 3/4 x minus 18 over 4, and that simplifies down to minus 9/2. So the y-intercept there is negative 9/2. Let me come over here and do the same thing. I'm going to use this point right here. So I'm going to say y minus 0 equals 3/4 times x minus a negative 1, which is also the same thing as x plus 1. So that's going to give me y equals 3/4 x plus 3/4. Let me ask you guys this. Is 3/4 and not negative 9/2 the same? Obviously not. Those y-intercepts are different. So because I have the same slope, but different y-intercepts, I would say these two lines are parallel. If you want to skip all the work, you realize you could just get the xy coordinate plane, you could just graph them, and you could see that they're obviously not on top of each other, and they have the same slope, so they would be parallel. Okay? All right, so once again, as a review, big thing, you need to make sure that you know how to calculate slope, okay? Slope is going to help you determine if you have same slope, opposite reciprocal slopes, or none of the above. Once you check the slopes, then you can check the y-intercepts to see if you're dealing with parallel lines or coincident lines, okay? By the way, if a line is not parallel, not coincident, and not perpendicular, we would just classify it as an intersecting line, right? So just two lines that kind of like cross, but not necessarily at 90-degree angles.